Hello everyone, I am Andra Doyle. I'm in Miss Benzi's online quantitative literacy class, and I am going to be doing my Excel report for Module 2 probability. And I'll go ahead and get started. I have my screen shared here, and Miss Benzi asked us to scroll through at the beginning of our report and show our formulas. So I'll do that right quick and get that out of the way. Here are all my formulas I used. Just scroll through right quick and get this done. You see it just expands it so you can see all the formulas used in Excel. And that is that. Let's get back to the top and I will start my report. Question number 1 is a question about a survey used about people's opinions on whether or not you should use federal bailout money for homeowners in default. And this was a 2008 survey conducted of 500 men and 500 women. And we found that about 50% of the people asked said no. Then we learned if you choose a woman, the probability that she said no would be 43%. And if you choose a man, the probability that he said yes or not sure would be also 43%. The probabilities used here are empirical probabilities because they were actually calculated from a survey or an experiment that was unbiased and random samples were taken. So we could, from that, form probabilities to project outcomes for what we could think would happen on a larger population. Number 2 is a probability question about rolling 2 dice at the same time. We were asked to find the probability of getting a sum of an even number, which would be 18 out of 36. We were also asked to list our answers in reduced fraction, decimal to the thousandths, and percent to the tenths. And I made a chart for each one of my results. And next I found that the probability of rolling a product of a prime number would be 5 out of 36. The sum of being a multiple of 3 would be 12 out of 36. And finally, getting a product of 12 would be 7 out of 36. And here are all my charts tables that I made for sample spaces. Question number 3 is about the expected outcome of winning a $5 lottery ticket in Illinois. This problem, we were asked to create a table using odds to calculate probabilities for each numerical outcome from the player's perspective. I found the expected outcome would be a loss of $1.93 for the buyers and a gain of $1.93 for sellers. We were also asked to find the seller's expected outcome for selling 5 million tickets, and that would be this big number right there, $9,700,000. I also done some research of my own for the state of Arkansas's Lottery Commission, and it turns out the state's revenue for scratch-off tickets for the month of July only of this year soared to $34.4 million, and that is up from $29.5 million just a year ago. It looks like the state's making all the money when it comes to lottery tickets, and the odds are not in the buyer's favors. On question number 4, this is the odds in favor, odds against. for an event with a probability of 9/13. We were asked to find the odds in favor and the odds against, and we were asked to draw a diagram for both odds in favor and odds against. And we were also asked to label all results as fractions, reduced fractions, decimals to the nearest thousandths, and percents to the tenths. Odds in favor were 9/4, and odds against were 4/9. Question number 5. We were asked to create a spreadsheet by following the data presented to us in our exam. We were also asked to find the probability that an individual was a woman who was in the Air Force, Marines, or Coast Guard. And that would be 14.4% if she was a woman who was in the Air Force, Marines, or Coast Guard. Then we were asked to find that a man was that he was a man and in the Army would be 86.4%. I've also created a graph to show the total number of men and women for each branch of service. Additionally, I was asked to find the number of men within the Army, which I already said was 86.4%, and then the women, given they were not a Marine, which would be 15.5%. And the final part of this problem, we were asked to find the probability that an individual was a man not in the Air Force, and that would be 87.6%. And all of my results are listed here on the side. And in the final question, this last question, we were dealing with binomial distribution formulas in order to determine whether or not we would believe a classmate who claims that they have a score of an 8 out of 10 on a quiz by randomly guessing at answers. I found that the probability of this happening would be extremely small, and I would not believe this classmate's claim based on my calculations. It would be 0.038624% chance of happening, and that's just way too small to believe that. And that concludes my Excel report for Module 2 probability. Thank you very much. Have a good day.